What? So n is odd. The sequence ends if n equals 1. I mean, I guess the logical way to do this is to do it in just a while loop. So, int length. Hey, good to see you, man. Welcome to the room. The int length equals 0 while n does not equal 1. I'm assuming every item has its callout sequence. Yeah, it's good. It's always good to see people drop by. Always good to see people practice. We've been having a very interesting set of chats in the past few days, so I'm hoping today ends up better. So while n does not equal 1, if n mod 2 is equal to 0, we're going to do n equals n over 2, else n equals 3. Let's do 3 times n plus 1. Cool. We're going to do that, n equals 3 times n plus 1, and we're going to do length plus plus. And then, I don't think it should ever end up at 0. And at the end of this while loop, we're just going to return length. Length. There you go. Length. Sweet. Really? Okay, let's do length of 1 to start. Nice. Cool. Very reassuring to actually be able to solve questions once again. The new session is, I think, what I needed. First fit room. You're given a list of integers, rooms, and an integer target. Return the first integer in rooms that's target or larger. If there's no solution... Oh, goodness. That's a very fast solution. Okay. Turn the first room. So that would be 20. Can we sort them? I guess not. Cool. For int I in rooms, if I greater than or equal to rooms to target, return target, return -1. Goodness, I forgot how easy some of these were. Really? Sorry, return I, not target. Yeah, there you go. I think a binary search would be the way to do it. Okay, let's see our mediums. Central linked list. Given a single linked list, return whether the value of the middle node, if there's 2 middle, return the second one. Bonus, solve using O1 space. Okay, so I think one way to do this is to utilize 2 pointers. So what we can do with this, right? What we can do is to say we have a slow pointer and a fast pointer. The slow pointer moves 1, fast moves 2. Welcome. Okay, so if the slow pointer moves 1 and the fast pointer moves 2, alright, if the slow pointer moves 2 and the fast pointer moves 1, let's say we have this list, right? We have 0, 1, and 2. They both start pointing to 1, to 0 rather. Then the slow one moves up to 1, the fast one moves up, plus moves up to 2. And at this point we check. I remember learning about this recently, really. Yeah, it seems like 2 pointers would be a very good approach here if we can actually leverage the property, because if it's odd, it's one thing, if it's even, it's another thing. We can say if fast.next equals null, return start. Then, if let's say we have 0, 1, 2, 3, 4, 5, that should be 6. So our slow pointer begins at 0, fast pointer begins at 0, slow points to 1, this points to 2, this points to 2, this points to 3, 4, this points to 3, this points to null, to 5, and 5 to next is null. Then say if fast if fast equals null or fast.next is equal to null, we return start, because that gives us 2, 3 in the middle, and that points to there. And I think that should be a valid solution to this. All right, let's give it a shot. So if node equals null, return 0. Then int slow equals node, int fast equals node, while fast not fast, fast does not equal null, and fast.next does not equal null. Slow equals slow.next, and then fast equals fast.next.next. And then here we should be able to just return slow. There you go. Okay. LL node. And then also litless node. Sweet. Let's go. See, this is why sometimes it helps to think about it other ways. Goodness, it's such a morale booster when you can actually solve questions, man. Such a big morale boost. And also, this guitar, like, chill guitar beats playlist is really, really nice. What I think I'm gonna do is quickly here, I do want to share this playlist into the chat. Let's do this, right? Gotta copy the playlist link. I'm gonna go into my Nightbot commands here and take a little second to set up a Nightbot command to drop in this playlist, because I do want to give credit where credit's due for the playlists that I use. Playlist. Cool. So now I believe typing !playlist should share the playlist that's currently playing, and I'll try and keep this up to date based on what's playing. Alright. Okay. What do we have? Okay. Partition tree. Given the root to a binary tree, return a list of 2 numbers where the first number is the number of leaves in the tree and the second is the number of internal non-leaf nodes. Sweet. Okay. This one shouldn't be too difficult either. Okay. Alright, so how do we actually do this? Couple things. If this was a language like Python, we'd be able to pass up a tuple of we actually straight up just can do that. So what we're gonna do is do a post order traversal, just because that's how I feel like doing it today. Okay, so post order. We're going to do left, then right, then center. Then, afterwards, what we're going to do is, at each level, check if it is a leaf or an internal. Update respective array, pass back up, sum at level. So what we're going to do, right, is to say at each level, we're going to do an int array of current equals new int of size 2. What we're going to do is say that the 0th index is going to be our leaves, 1 is going to be our nodes. So at any given point, we can update one of these values, because any item is either a leaf or a node. This means that to say can say if root dot left is equal to null and root dot right is equal to null, we update it to be a leaf node. So current at 0 is equal to 1. One thing that I think is important to do here is to say if root equals null, we return new int array of size 2 because that's auto-filled with zeros. So that's that, current plus 1, there you go. Else, if it's not a leaf node, it has to be an internal node. So then what we do with this information is say that current at 1 is equal to 1. Easy. Then, I think that this is going to be valid syntax, but here we return current wait, how do I actually do this? Let's do this. I guess we just do this. Left equals solve root dot left. Int right equals solve of root dot right. And then return actually current at 0 equals 0 plus equals, how do we actually do this? Left at 0 plus right at 0. And I think that should do it, and then current at 1 plus equals left at 1 plus right at 1. That should allow us to sum up both left and right subtrees, and then we can return current. And this should bubble up all the way. Sweet. And boom, contest done. That was what, 15 minutes for 4 questions? Oh, I'm so happy, man. I am so happy. Okay, I'm feeling a lot less bummed out about this Google interview. Leaf and internal nodes and tree. Well, I'm not really sure what to do for the next 45 minutes, to be honest with you, because I mean, I finished this session. Yeah, I'm really not sure what to do now. I mean, I could check, try optimizing them, I guess, but I haven't finished a session in so long, it's not even funny. Leaf and non-leaf node. Pretty much, yeah, any node. Google is next Tuesday. So, let's see what everyone else is up to here. How's the scoreboard looking? Because I think those first two were very, very easy. Yeah, okay. No, I feel like we should be done here sometime soon. It's my final interview, man. I have I think it's 5 back-to-backs. I start at 10 a.m. and I finish at 3:30. It's like 45-minute blocks, and then I get, I think, a 15-30-minute break in between to kind of refresh my brain. Oh, this one's... Oh, Daniel Solomon in Python, okay. But yeah, no, it's gonna be... Yeah, it's... Google does not take their stuff lightly, honestly. But, dude, I'm hoping, fingers crossed, because last year, in like June, I made myself a promise. I was like, hey, I am going to get, like, I was driving through the kind of Seattle area that's around where I'm located. And I was looking at their offices, they have a very large office in Seattle, and I told myself, hey, next year, I'm gonna have an interview here. I'm gonna have an interview kind of for this position in this office. And I mean, I got an interview for a winter internship with them, made it to the final round, and just barely didn't squeak past. I had 3 interviews with them, just barely didn't make it. And I was like, well, you know, I kind of achieved my goal. I had a job interview. Then I did their OA for their full-time position. Aced that, got this final, and I'm not in very good standing because their initial invitation to the final interview. Hey, thank you, man. I appreciate it. Yeah, their initial invitation went to my spam box, and I didn't see it for like a month. And they called me when my third interview of the day should have been, and like, hey, are you gonna actually, do the interview? And I was like, I don't remember being invited to one. So I got lucky. The guy was nice. He rescheduled me for about a week and a half out. And for about that whole week, I've been practicing this, trying to get good enough at this to actually get a job. But at this point, I've accepted to use Google as practice for Microsoft because I have Microsoft on the 27th. So my Microsoft final hopefully should be easier than the Google one. Google's the only FANG position I've actually managed to interview for. Facebook did not acknowledge me, Netflix did not acknowledge me, but Google was kind of nice. I kind of like this little tree here. I feel like it gives a little bit of a nice nature aesthetic, and this candle smells pretty good as well. Okay, I don't know what to do. I mean, I'm not gonna, hey, bravo. These are pretty simple questions. Are so much better than yesterday. Garbage. Okay. I don't want to like kick people out of a session. I don't know how to actually like continue here because I just want to throw another set of questions on. Honestly, wasn't expecting to get this many people in here regardless. But let's see. Did I actually solve any new ones? Let's see. While that's going, yeah, this is where I'm at with these questions. Today I want to do 2 hours. So once we finish this session, I'm trying to hit 2 hours. So we're 20 minutes in, and hopefully should be on here up until about maybe 3:30, 4 o'clock Pacific Standard. And I try and do these at 10 a.m. Monday through Friday, PST. It's just the time that ends up working for me, and hopefully I can help other people as well with it. All right, we got 2 people done. All right, 2 people holding us back. All right, let's see. Okay, forgot to change static. So, what are you up to, Ben? Student, kind of, employed. What's your CS career looking like? It's been so long since I've practiced, yeah. Go away. I figured out how to ban people yesterday, so I'm gonna do it as well. Oh, wow. Yeah, for a high school student, you're doing very well. Especially with some of these questions involving data structures like trees and linked lists. I remember those were very, very big in terms of kind of difficulty for me to learn. But yeah, no, you're doing great as a high schooler. What? Wish I was kind of where you're at as a high schooler. Let's see. Curious about your profile. Okay, that's hey, you've got more hard solve than me, man. USACO. I have honestly no clue what that is. Need to relearn Python from 445. Okay, let's see them struggle. I wonder if I can like pull up a second window and do another session while this one's going on. But yeah, USACO, I've never heard of that. Let's see. Can I do this? Can I do binary search and can we maybe start another competitive programming but for high schoolers? Wow. No, I was considering doing like ICPC. But I didn't have the time to actually prepare for it. I know a couple of my friends did prepare for ICPC and actually did it. and 3 classes, 1 internship, 1 part-time job, and job hunting. Eesh. What is this? Man, competitive. Maybe once I finish my university degree, I'll actually. All right, take care, man. Thanks for stopping by. Man, I kind of wish I. Dude, it's so nice. I'm really happy with this camera. Get an ASMR microphone? Nah. I genuinely do not have enough ports to plug anything else into this laptop. Like, to put it into perspective for you, I think I'm using every port, and then on top of that, I have a, on top of using every port, I have a splitter into what I'm plugging my camera in. Because I have an HDMI cable plugged into the HDMI port, then I have a USB-C to HDMI adapter plugging in my second HDMI for my third monitor. I have my headphones, I have my one USB port being used by the keyboard, one being used by the mouse, and then the other one is being used for my camera. To build another port, I just might, man. Trying to bully them into moving on to the next one, because I don't think I can actually. Yeah, I'm already in a room. I can't. Let me just get this one. Use my 372 knowledge to build another port, dude. I mean, do I have Logisim installed still? I don't. My computer that had it installed died. Let's see. What are you working on? You are working on the. This is the tree one. I love the cheating note. I love the fact that you just kind of acknowledged that. Because see, passing it up through the chain is the kind of the best way to do it, but it definitely takes a lot of time to figure out how to actually work with trees that way. Okay, so let's go through our questions while they're working on that and do a time and space complexity analysis. So this one is done in, this is O of n time as well as O of 1 space. Cool. Yeah, and then the reasoning behind that is that we're only using variables, but we also need to run through it n times because we are running in this while loop until we end up to 1. I'm not sure if that really is O of n time complexity. However, that's what we're gonna assume that it is and kind of go from there. Next question, we have this one. There is definitely a faster way to solve it, but this is the way that I went with. This is, again, O of n time and O of 1 space. So that allows us to, the reason behind that is we're just, I mean, actually, I'm not sure if it would be faster to sort this and do a binary search because that still leaves us at n log n, while this one is O of n at the worst. Move on to another session. Okay, this one, slow fast pointer is going to be n over 2, which is still O of n time, and O of 1 space. Very fast solution. Very proud of this one because the reasoning and the intuition behind it takes a bit to get to, I think, but what's it called? But yeah, it takes a bit to get to. Ghastly noises. Yeah, I've done them all. Yo, hyperspeed. Yeah, no, it's been nice to warm up to this. But yeah, the intuition behind this one was very cool because it allows you to. My first thought process was kind of a 2n solution, which would have still been O of n, but it would have been slower to run through the whole list, count the amount of nodes, and then traverse again, and then do that. However, the fast and slow pointer would allow you to. It would allow you to actually be able to find the middle without having to look through it twice. Alright, let's ready up for these next ones. Dude, I love these questions. They're so nice. It's so nice when you get like actual doable, non-obscure 40% success rate questions. I love it. It's great. Okay, once we go up to the next one, I feel like this is where my luck's gonna like run out for some reason, and I am going to just lose it because it's gonna be very difficult questions. All right, let's see. Once told me the world. Oh no, here we go. I need the sharpest tool. Alright, it looks like we're gonna have to wait because I think, what person's idle? I think Rocky's idle. Alright, let's see what we got for these next questions. Okay, recurring character. Given a lowercase alphabetical string, return the index of the first recurring character in it. If there are no recurring characters, this is a loop with a hash map. So what we're going to do is loop through, add characters into characters into the set. If set contains character, we found repeating. If get to end with no repeat, return -1. So return the index of the first recurring character. So yeah, let's do that. For int I equals 0, I is less than nums.length, or s.size. Cool. I++, and we're gonna up here set up our hash set of characters. Man, I love the fact that these are O of 1 access and O of 1 insert. Integer character. Sweet. And we're gonna go ahead and say if not set dot contains s dot char at I. There we go. I think I'm already missing one. Then here we need to add to set dot put s.char at I. However, if it does contain it, else return I. Down here, we just outside of the loop return a -1. Cool. If that's fine. That's just a typo. Once again, a typo. This closes that. That closes that. Cool. Still no. S.length. Ah, come on. It's add. So many typos, man. So many typos for that. Alright. Let's see what we got. Okay. Verify max heap. Given a list of numbers, return whether it represents a max heap. That is, for every I, we have that is within bounds Ooh, this one seems kind of interesting. I do want to leave this one for the end. Merging binary trees. Given two binary trees, node 0 and node 1, return a merge of the two trees where each value is equal to the sum of the values of the corresponding nodes of the input tree. If only one input tree has a node at a given position, the corresponding node in that tree should match that input node. Okay, this one's going to be interesting. Integer to I hate it. I hate the Roman numeral one. Okay, let's do it. First of all, I guess let's go do this max heap thing. Because I just want to be able to solve this one. I hate to. I think we can do this in n squared. Because I can't really think off the top of my head of a way to do it faster. So we're gonna do it this way, I think. This way. And 3. Check 4. I think potentially what we could do is, because if we validate the top item, we know that everything below it is valid. So let's do this, right? Let's do a hash set of integer checked. Now that is annoying. It's like converting to base 10, but worse. So we're gonna do that, and checked equals new hash set integer. And we're gonna basically just validate as many things as we can at once. So to say for int I equals 0, I less than nums.length, I plus plus. I'm gonna say if checked. Oh, hey, good to see you, Alphasan. It's been a while, huh? Decided to do a bit more questions today and decided to try out a new camera angle for this webcam up here. I think it's pretty nice, especially with these lighting effects. It's not checked dot contains. Don't want to have to calculate the fancy copyright in the credits. So if check dot not check dot contains nums I. So if we haven't checked this index, perform check. Otherwise, do nothing. And then here we're going to return true, because if we've made it all the way through the array doing all of these checks, then that's going to mean that we did it correctly. So how do we perform this check, right? Need to do one check for 2xi plus 1 and one check for 2xi plus 2. I mean, actually, we might not need this hash set. We may be able to just get away with checking every one distinctly. Yeah, let's do that. Let's get rid of the hash set for now, because the hash set is a way to do it, I think. I think you could just solve this recursively, but I don't want to solve it recursively right now. If we have time at the end, I'll come back and do it recursively. Okay, so let's do it this way, right? If 2 times I plus 1 less than nums.length, and nums at I is greater than nums at 2 times I plus 1, we're going to return false. What this allows us to do is to say, hey, is it in bounds? And if that number is greater, we can return false. And then also, I think following the same logic, can I move this a little? I can't move it a little bit, I'm gonna have to move it a lot. Let's just do it here. +2 if it's in bounds. Actually, it has to be less than, I think. It's a max heap, not a min heap. +2. And I think by just getting rid of this space here, we can make it fit on one line. That's a weird indent, but sure. Okay, so that, return false, return true. Cool. Bada bing, bada. Boom. Slow, but it works. The recursive solution is faster. I kind of want to do it recursively now, though. Let's try and do that. I mean, we're less than 10 minutes in here. So let's do this, right? Let's do Boolean solve recursively recur of nums and 1 bool solution equals recursive of that, and we're going to return solution. Let's do, okay, so public boolean recur of an int array called nums and int index. Cool. We're going to do it like that and have it be an index. Cool. And here what we're going to say is, first we're going to check all the way down. So boolean left equals recur recursive of nums and bitwise. Sweet. Okay. Of nums, so doing index times 2 plus 1. Boolean right, we're going to keep track of left and right, equals recur of nums at index times 2 plus 2. Okay. I love the different attitudes to it. Okay, so we're going to return Boolean of, so here what we need to say is, I think this conditional try this. Boolean cur left equals this one. Right. 2 times I less than nums dot length, and it's like that. And we need to close this parenthesis off. Boolean cur right is equal to this conditional. Okay, let's do that. Index like that. Just get rid of this one. And I think if we return the and of all of these, we might have it. +1. Okay. Oh, just nums and then that. Forgot to add my parenthesis in the correct place. I actually don't need this at all. Two times index. Hey, good job, man. Okay, length index. Gotta make sure I change all these i's to index. I'm gonna be upset if the solution just does not work. Index. Okay, I think that should be it for compilations. Stack overflow error. Alright, well that didn't work, so we're gonna come back and do this one later. Okay. Merging binary tree. So we need to, I think, put them into some sort of representation where, 5 lines. Amazing. Okay, how can we figure out where things are in the tree respectively to one another? There has to be a way that we can store this. Because doing so, like just recursively with both of them does not really work. So, how can we go about merging two trees? Because it needs to be the sum What if we were to convert this to like a list representation of a tree? That might actually be the way to do it. Okay, here's what I have an idea for, right? It's a bit of a dumb idea, I think, but we take this, because we know that the tree can be represented in array form, with the left tree being, I think it's like 2i plus 1, and then right tree of 2i plus 2, right? What we can do is make a map where we store the first tree in the map with key equals position, val equals, well, the value, and then traverse second tree and add that in. Then rebuild the tree. So we deconstruct both trees, sum them, and then reconstruct the tree. Although that does not seem like the absolute best way to do it, I think. I mean, what's the hint here? Recursively merge one tree with another. I mean, how do we recursively merge these trees, and how do we then how do we figure out where we are in the tree is my question here, because so I assume this then is not really a good way to approach it, because I mean the hint says to recursively merge it. So let's try and think of a way. Wait a minute. We can always do something along these lines, right? Let's make a helper method just to make my life easier here. Public tree helper equals helper, which will take in a node 1 and node 2. So, couple things that we need to do. We can, in fact, recursively merge these in. The only thing here is we'd have to, I think, once again do a post-order traversal. Because we can't modify, we can't know what the sum or whatever of a given node should be until we've done its predecessor, its children. So we do a post order, right? We go as far left as we can. If a node is null, we pass null as its left and right children. Then, upon summing, if a node is null, we just do +0. And that should be it. I don't think that should be an issue. Yeah, I mean, that sort of makes sense in my head. It makes a bit more sense than deconstructing the entire tree and reconstructing it for sure. Let's readjust this keyboard a bit, make sure it's straight. All right. So how do we actually do this? So let's say this, right? We need to do our post order traversal. So we do helper, helpter, helper, okay. So we need to make calls to helper for left and right. So here's what we're gonna do. We're say if node, okay, tree node 1 left equals null. Tree node 1 right equals null. Tree node 2 left equals null. Tree node 2 right equals null. So what this allows us to do is set up our nodes as nulls. Then to say, it's a bit I guess, overly written out, but I think it should just work. If node.left not equal null, what we're going to do then is say node 1 1.left node 1 left equals node 1.left. So if node 1 does not equal null, node 1.left, cool. And node 1 right equals node 1.right. What this allows us to do is not run into null pointer exceptions ever while trying to call node 1.left or node 1.right. And copying this, we can apply the same logic to our second node. Node 2, node 2, node 2. Cool. Node 2.left and node 2.right. Okay, so now I think we should actually be able to do our post order traversal. To say helper of node dot left, not node dot left, node 1 left, node 2 left, and helper node 2 left, node 2 right. Cool. So now we actually need to do the summing up. So we can say if node 1 is equal to null, then node 1 equals new tree of value 0. There we go. And cool. If node 2 does not equal null, node 1 dot val equal plus equals node 2 dot val. Otherwise, it stays the same and we don't modify it. And here we can return node 1. I think that should be it. Let's do recur. Let's do return helper node 0, node 1. And let's see how badly that does not run. Runtime error, stack overflow. Hey, thanks for the follow, QQ. Very interesting name. Alright, let's see. So, let's order. Where are we running into a... So these are all null. Oh, we are forever actually going to be calling these. Let's do this, right? If node 1 is equal to null and node 2 is equal to null, return null. Just do that. That should break the cycle. Still wrong answer. Alright, what did we get? Ooh, we dropped a node. We dropped a value somewhere. We dropped a value somewhere, and that's all that we got. Okay. We're getting very, very close. So let's do this real quick. System. So if they're both null, how do we actually do this? Okay. System println node node 1 dot val plus node 2 dot val, and see how fast that crashes. Okay, we get 5 and 8. Let's move this up by 1 right here. That should allow us to get the actual 3 and 5. Then we get 3 and 5. 5 and 1. Where do we get 5 and 1? 0 and 7. There's no 5 in this second tree. That's very odd. Very odd behavior. I'm not quite sure why we're seeing that. Why are we okay, so let's look at this, right? We're seeing a 3 and a 5, which makes sense because it's here and it's here. Then this 3, it makes sense to be there because it's just there. But why don't we ever hit that 3 is my question. Why don't we ever hit the second 3? So if both of these nodes are null, we don't do anything, right? If node 1 is not null, we can update these to be non-nulls. If node 2 is not null, then it's that. This part makes sense. We just go left and we go right. We go left and we go right. Okay, we got a wrong answer, but let's see just how wrong our answer is. We hit a 3 and a 5, which gives us an 8. Then we somehow get an 8 and a 1. Which doesn't really make sense to me, but I'll take it. And then a 0-7. I mean, 0-7 is working. I think it's because... Wait, where am I getting this 8 from? So, I think are we doing node 1, and node 2. So this, it's left tree and then right tree. So we're seeing an 8 in our left tree. So that's that, that's that. There we go. Runtime error. Null pointer exception on line 47. That's okay. That is fine by me. That's what I was thinking. Boom. Dang it. I thought I got close here. I thought I got it. What's our issue? 5, 2, 3. So we are summing that. Okay, so we're close. We're getting close. Node 1 does not null. Node 2 not null. So let's see. What we're doing is right away. Node 1 left. Node 2 left. So starting here, neither of them are null. So what node 1 is not equal to null. Node 2 should be node 2 left should be equal to 5, while node 2 right should be equal to 5, while node 1 right is equal to 2. So let's say we go down this, we have a null and a not null. So we do that at that point, node 1 is equal to null. So why? Oh, because that is I see what the issue is. We're never actually adding this node to the tree. How can we go about adding said node to said tree? That's the real question here. Nice. GG, man. GG. Beat all of us to it. Okay. So how can we actually like add this stuff? Okay. We got our nodes. How do we add nodes? It's my only issue. Because I think here, if I actually... You go higher than the rate of inflation in Venezuela. Node 1.val. I think if I do that, we should see the 5. So our tree has 5, 5, 6, 3, 2. Cool. How do we add said node to said tree? I guess what we can do then is to say, maybe pass in like a parent node or something. Like you built a new tree. Add missing nodes from tree 2 into tree 1. The lower actually I speak for the trees. Okay. Let's see, how can we actually... I won't try 4. Come on, you got it, man. How do we add... Return node 1. So let's think about it this way, right? We have, at this point, the node 1 that we are going to be returning. Okay, let's do this. Left equals 0. Left equals that. Tree right Now, at the end of all this, right, we can say if node1.left is equal to null, node1.left equals left, if node1.right equals null, node1.right equals right. We're just gonna shove it in there. Where did I make a typo? All right. Something along those lines. Boom. Okay, let's get rid of the print lins. The issue was that it just wasn't adding in the node if it wasn't tree 1. So I just added it. Cool. Very slow, very chunky, but it works. I solved it, and I think at the end that's all that matters. Yeah. Explain how you did it. I want to know. Okay, I definitely can. Okay. So, basically, I mean, this helper function doesn't need to be here. I just did it for my own personal sake to rename these variables. So what I did was I did a post-order traversal, meaning I solve it bottom up. What I did was I just set node 1 left right, node 2 left right to null, because this way I avoid null pointer exceptions when trying to traverse left and right. Then basically I said if node 1 and node 2 are null, we just return null. This allows us to not continue if, let's say, both of these have a leaf node down here. If we're both at leaf nodes, then we return it and we don't do anything about it. Next, if this node wasn't null, we update its left and right to its actual left and right, otherwise we leave them as null. Then we do the same thing for node 2. If it's not null, we update its left and right. Then we do the post-order traversal with its left and right. Then we know we need to sum up these nodes. If at least one of them was not null, there's going to be some value that's present there. So if node 1 was null, we update it to have a value of 0. Then, if node 2 wasn't null, we add its value to node 1, and we know we can do this because we already know this is not null. Then, because at the end of this we're going to be returning the actual node we're working with and all the nodes that are attached to it, we basically say if node 1 had a null, we just attach whatever came up from the tree to the left, and if the right was a null, we attach whatever came up from the tree to it. This works because we either return a null or the summed up node, and that node needs to get reattached to the tree. And by doing that, it's fairly slow. I'm pretty sure I could just eliminate all of this. Like a lot, I'm pretty sure this entire chunk could honestly be eliminated. Because, let's try it, right? Let's do this. Just get this null check. We're going to put the null check up here. And then let's do node 1.left, node 2.left, then node 1.right, and then node 2.right. And I think that should honestly work. Yeah, no, see? Null pointer exception. That's what I was trying to avoid. Let's do it like this. Run it again, make sure it actually works. Cool. Now comes the actual difficult question of all of this. It's about drive, it's about power. Alright, so how can we do this? Given an integer, n, return its corresponding Roman numeral. Roman numerals contain the following symbols, representing values in the following list. IVXLCA. Symbols are typically written largest, smallest from left to right, and can be computed by summing the values of the symbols. However, in some cases, when a symbol of lower value is to the left of a symbol of a higher value, the lower value is subtracted from the higher one. How do we actually approach this question? This is, I think, the most difficult one. So it's definitely a string building exercise, but the computation is where it becomes difficult. So, obviously the dumb way to do it, right? No symbol is repeated more than 3 times. Symbols V, L, and D are not repeated. And 3 was disgusting. X plus I is 12. X, I, V, L, and D are not repeated. Technically, actually can't be repeated more than 3 times. So, the way I think to approach this question is somewhat similar to how we would go about tackling converting, like binary to decimal. Start on the rightmost side, grab as many of those as we can, and then continue to the left. So let's do start with biggest and continue to the left. That's going to allow us to sort of systematically get rid of the bigger ones, and then eventually end up with just smallest ones. So, what's the string? Yeah, okay. So, I think I give up. I don't want to do 4. Come on, man, we got 20 minutes left. Give it 20 minutes. Keyboard, this is the Keychron K6 or K2. I can't quite remember. Here, let me pull this aside and figure out which one it is. The keycap set on it is custom, though. Cron K2. It's a really nice, yeah, I think it is the K2. Maybe K6? I've been a big fan of Keychron boards. They're, relatively affordable for what you get, and, they sound okay. I put some padding in mine and tried to lube the stabs a little bit, but yeah, so it is this one right here. It's the one that I have, and I bought a cheap Amazon keycap set for like 20 bucks to put on it. I'm not like Master Keyboard Warrior. I did buy this one with the aluminum frame and the red switches, just because I bought browns last time and I realized that tactile really wasn't my thing. So, where's my headphone audio here? Let me mute this and give you a bit of a keyboard sound test here. So this is the Keychron K6 with Gator on reds, a bit of padding, and some lubes on the stabilizer, so they're still clacky. So it's definitely not your super high-grade fancy keyboard, but been typing on it for about a year and I absolutely love it. Though, you probably can't see it because it's blacked out, but I do have a wrist rest that I use with it, because without it, the typing angle is absurdly high. So I just bought this, $5 wrist rest off Amazon, and it's been doing wonders. So, back to this question. Answer is in the question. Read carefully. Okay. Return its corresponding Roman numeral. So Roman numerals contain the symbols representing the values. They are written largest to smallest from left to right, and can be computed by summing the value of all the symbols. However, in some cases, when a symbol of lower value is to the left of a higher value symbol than the lower value subtracted from the higher one. So I before V we get 4, I before X, X before L, C before D, C is before M. No symbol is repeated more than 3 times. I don't understand what that means. See the constraint of the question, n is less than 3,000. See the cases. No, I am. Okay. Let's see. So we have 3,000, right? Obviously, we need to start checking up to, like, you know, the thousands placed in the... And now, how do we actually do this? I think the question itself is just fairly intimidating. And that's why it is sort of difficult to do. Have we all finished? Actually, maybe we can actually just skip this one. Oh, hey, welcome back. Hold up. Hold up. All right. Maybe Rocky's the hero that we needed here. Maybe Rocky can solve this 4th one. Yeah, we're all stuck on this Roman numeral question. We were about to give up, but seeing that you joined, maybe you've got an idea of how to solve this one. Feedback. How? How do you do this? If n is less than 3,000, right, what difference does that make? See the constraints of the question, n is less than 3,000, and then see the cases. What does that do for us? Brute force. There's no way it's brute force, man. There's absolutely no way this is meant to be a brute force question. I would love it if it was, but I don't think it is. Oh, one more thing about this keyboard, if you notice, I think right about there, yeah, this has a short shift, but the keyboard set I got didn't come with a short shift. So I call it the gamer shift key because it's the only gray key on the entire keyboard set. But I do love the aesthetic of this one, it's really nice. Some case, okay. If a number is great, okay, let's try this, right? So, figure out how many times 1,000 can go into the number. Right in that many. Only do another round if we skip 4. I'm down to just move on. I'm gonna give up on this. Because this question is, y'all can abandon me. I gave up on it. Okay, right in that many. Then, check how many 500. And maybe do that repeatedly. Alright, I gotta take this phone call, and then I'll be right back. There you go, wrong screen. Okay. Just like SS and TV or something. I think you can only see after you've given up. I think, so this question itself is not particularly difficult to solve until you get to a place where, yours is logging. Yeah, I think, yeah, the question itself is not difficult until you get to a point where you need to add numbers in front. So let's go ahead and do this, right? While n so first of all, we're going to obviously need this loop. N is greater than 0. We can do that. Then, to say string Roman equals an empty string. If n is greater than 1000, greater than or equal to 1000, then oh wow, that is pretty short, yeah. So we're going to do this, and then we're going to say if n's greater than 1000, Roman plus equals plus an x. For is x 1000? I think x was m. Let's do this, right? And then n minus equals 1000. And we're going to follow the same logic to go through and set up the basis of this solution. And once we set up the base, we can try and figure out a way to actually else if n greater than or equal to 500 plus equals d subtract 500. Continue to do this over and over and over. 150, 10, 5, 1. Hey, good to see. Oh, no way. Congrats, dude. Congrats. Yeah, I don't know if you were part of the Ahoy train from Twilio, but I aced their OA as well, like way back months ago. And they kept sending us these like Ahoy emails. That got a little bit frustrating after a while, I'm not gonna lie, but congrats. Is this your first interview? Is this like an OA? Is this your final? How's that looking? MD, this needs to be a C. This needs to be an L. This needs to be a X. Whew. Yeah, no, dude, that's kind of... Every time you get one of those interviews, you become so nervous. Is this your first, like, on-site, or... B... I misunderstood the problem. What'd you think it was? 1000, greater than 50, 10, 5, and 1. This is going to be minus 500, minus 100. They were trying to get the number from the string. No, yeah, that would have been a lot easier. It would have been a lot easier if you could just get the number from the string, but unfortunately, that's not what this is asking. It's first on-site. I did the away last month. Guys, hey, part of the Ahoy train. Yeah, no, that was the biggest meme in like all the CS servers going around. One thing I would recommend is, here, let me see if I can get you an invite. Okay, here's this. This is a general large kind of CS Discord server that has over 100,000 members. So if you're looking for people who have done the Twilio interview and can actually maybe help you out, you know, tell you what to expect, that's the place to go. So I hope that might be a bit of help. But honestly, dude, my first on-site was Google. My first on-site interview was with Google, and that was absolutely petrifying because it's like it's your first one, and it just has to be a FANG company. When I tell you I forgot, yeah, doing questions tagged on leak code, yeah, those are good. It's always good practice. I definitely recommend talking to some people who have already done it, because they can actually provide you with maybe more pointers than just general tagged leak code questions can. Return Roman. This is not going to work for all the cases, but I think it should work for maybe just this first one. Easy. Okay. So now, XI. Okay. So, let's do this, right? It doesn't actually... What we need to do, Google Onsites are insane. Yeah. Because they called me, and, you know, I completely understand, you know, because I come from an ESL background myself. Yeah, I come from an ESL background myself, but especially over the phone, and when they're on, like, their office phones, it's very difficult to understand the interviewer at times. So, I just kind of didn't really understand what was going on for a bit of it. Okay, so... I think the way to do it, right, is to check whether... Oh, wait a minute, okay. If it's 5,000, it's greater than or equal to 1,000, we can just add an M. But, okay, N is greater than or equal to 500. And less than or equal to, say 900? No, because 5... C before M, D before C. Oh, goodness, okay. It's all RNG. Your odds of getting the job depends on how good your interviewer is and if you can solve the problem or getting close to a solution, yeah. Hey, good, welcome, good to see you. No, the thing about theirs that I don't like is they don't provide you with like an actual... I mean, maybe it's kind of a blessing in disguise that they don't provide you with like a functional IDE to type code in, because then no matter how bad your code is, yeah, you can do exclamation point room. We have 4.5 minutes left in this one, and we're going to be doing one more after. But yeah, no, they provide you with basically just a glorified notepad with color highlighting, and that notepad, I guess, helps you to just focus on your algorithmic knowledge rather than syntax and like little things like that, which I think might make it a little bit easier. But no, quite literally, their whole thing is just like, it's a notepad. Okay, but the logic I think with this one is to say if it's within a certain range, you subtract it, 6, 7, 8, less than, say, 800, while n greater than 500, n minus equals 100, no, wait, this is the other way around. That's 500, okay. I have an idea of how to do this one. It's just tedious, and I don't have time to solve it here. If it's greater than or equal to 100, and less than or equal to silly Roman and his numerals. So I think the main point of this one really is to figure out what range you'd need to do. Let's say if you had 900, right? You would need to do, maybe not 900. If you had, let's say, 600 or 400? Okay, wait. Oh, so yeah, you have that. You basically need to insert like the hundreds place kind of below it until you get up to that value that you're trying to represent, and then subtract that value. Goodness. Okay, yeah. I don't have time to do this one. I've already given up on this one. But, guess, got more questions to solve after this. 5 days. This question should be at 8 because I mean I've done 8 problems today. I actually kind of like this. I mean, feels like it's a little bit sort of maybe less personal without having the camera pointing to my face. But I feel like this is also just like a really nice aesthetic to have. It's the lighting is entirely dependent currently on where my window's open to. So the second it gets dark, I lose all the lighting here. Okay. So minute 45 and then finally a new bank of questions. I think I'm gonna go ahead and head back through my questions and do the analysis on them to do kind of a time-space complexity. So, back to this question. This question has a O of n time, O of n space. The reason behind this and the approach that we took is we need to find the first recurring character. Sets, the whole point of sets is that they cannot hold duplicates. And we don't ever need them to hold duplicates. And because it's a hash set, it has O of 1 insertion and O of 1 lookup times because hashing is cool and very fast. So creating this hash set, we iterate through the string and add every character we come across. If at any point we find a character that is already contained in the set, we can then say that, hey, we found that recurring character. If at any point we don't ever find a duplicate character, we can then say there are no duplicates in this. He solved the Roman numerals. Freaking marathon. I gotta... Yeah, this is exact... Oh, goodness. This solution. GG though, well deserved. Okay. But yeah, so that's why it's O of n worst case, because in the worst case we check through everything and we use the set to store all of our characters. So next, verifying max heap. Could have done this recursively, but I didn't, so I'm going to Control Z back as far as it'll let me. It won't let me. Cool. So all I did was basically iteratively at each step check to see if the next one is valid, and if at any point we find one that isn't valid, we return false, and that's that. This one was a bit more of a marathon. I kind of explained this one earlier. I do think this one is O of n time and O of 1 space. Is there anything you want to show off? I think the beauty of understanding the different traversals of in-order, pre-order, and post-order is that it allows you to do things like this where you can either solve your tree top to bottom or bottom up. For example, doing a post-order, left, right, and then middle, allows you to do bottom-up solutions, while doing a pre-order, where it's center, left, and right, allows you to do top to bottom solutions. Let's see number 2. Where is it? There it is. Mask 1. If alphabet and mask does not equal 0, return I. What the heck is a... I'm not even sure what that operator is. A equals A bitwise OR. Nice. Alright, let's go. One more session and I think I'm done for the day because my brain's starting to get to the point where it's a little fried. I'm going to take this minute while it's loading to take a bit of a break, and I'll be back after to start the session. Okay, back to another session. was gonna do 3, but I mean I finished the first one very fast, and the second one didn't take too much time, so gonna be out for about 2.5 hours here for the stream. Okay, large to small sort. First number is the maximum, second is the minimum, third is the second max, fourth number is the second min, and so on. How do we actually approach this? I think the way to do this, I don't know why this solution came to my mind this fast, but what I think we should do is to say sort it, and then swap every other element. Easy. So let's do that. We're going to do arrays.sort nums. First is the max, and then that. So for int I equals 0, I is less than nums.length over 2, I plus plus. Let's do if I mod 2 is equal to 0, because no wait, 1 over 2, 1 mod 2 is 1, does not equal 0, because we need to swap the first element. Does not equal 0. We're going to go ahead and do our swap. So we're going to do int temp equals nums at I, then nums at I equals nums.length minus 1 minus 1 minus I. Actually, well, no, the 0th element is going to be equal to 0. So this does need to be equal 0. So we're going to do minus 1 minus I. So we swap the last one, and then otherwise we don't do anything, and return nums. Check. Hey, GG. Dude, you're the only person I think I've seen in a long, long time that codes in C++. My result was 3.9. Oh, I forgot to actually swap this. Nums at length minus 1 minus I equals temp. Nums at nums.length. Gotta make sure we actually do this correctly. Is my swap method wrong? Hold on. Nums at I equals nums.length minus 1. Never in the C++. I did when I accidentally wrote 4 pages of a research paper on C++ instead of C#. I mod 2 is 0. Println nums at I plus num space plus nums at nums dot length minus I minus 1. Oh, I read the problem wrong. I'm dumb. I guess what we can maybe do is to int reverse equals new int of nums dot length for int I equals nums dot length clear equals 0 I minus minus. What we're gonna do then is say reverse equals nums at I. reverse at my brain hurts. Equals 0 index. It's not the way to do it, but it's going to be the way that I do it here. Get rid of that. And then to say int result equals new int nums dot length. Oh goodness, yeah, I've hit that point where my brain doesn't want to solve these problems anymore. Okay. Int norm index index A equals 0, int index B equals 0, int norm equals false. For int I equals 0, I is less than the result dot length. Oh my goodness, dude. Calm down. Okay, so we're gonna do that, and then say if norm result at I is equal to nums at index A plus plus. Else, we're going to do the same thing except with the other index. Mental note, never interview for a position Archie has already interviewed for. Hey man, you won't be able to interview because he's just going to land it. Index B plus plus. Return result. Line 14. -1. Huh? But okay, let's just do this, right? Not nums at toString, nums at I. Man, this problem should not be giving me as much trouble as it has been. 9, 5, 3, 2. Oh, wait a minute. Norm equals not norm. There we go. Got TLE. Ah, dude, that sucks. Yeah, I hope it's not too terrible. Might get a TLE here. Oh, well, there goes that. Cool. Let's get rid of this println. There we go. It's a really bad way to solve it. Because, I mean, there's definitely a faster way, like 100%. Unobstructed buildings. You're given a list of heights representing buildings' heights. A building's height I can see the ocean of every building on its right as a shorter height. Return the building indices where you can see the ocean in ascending order. Cool. So we're going to make an array list of integer, one in place. Cool. Array list integer. Bruh. Oh goodness. List equals new array list. Cool. So what we're gonna do is do okay, we're gonna also do int max height equals 0. And then for int I equals 0, we're going to start from the other side. Dot length -1. I is greater than or equal to 0. I minus minus. What we're going to do is, let's see. Heights dot length. Okay, let's say gonna say if heights at I is less than, greater than, a shorter height is greater than max height. We do list dot add I. Cool. And then all we need to do is to say down here, max height is equal to math.max of the current height versus the max height. This should allow us to just do it every time. And what we're going to do is say collections.sort list, and then we're going to do an int array of size list.size. The ones I've seen use C++ since it's really fast. Result equals new int of size list.size for int I equals 0, I is less than result.length I++. We're going to grab it from the list. I am into competitive programming, sort of. That's really cool, yeah. You can tell when people do stuff like this constantly, because when they actually do solve these problems, it is very fast. In ascending order. Cool. See all my compilation errors. Lists.add. Cool. Gonna add it in. Sweet. Submit. Done. Bada bing, bada boom. Problem solved. Alright, I saw you copy some code last while. I just wanted to see if code was copied from other IDE or the internet. Cool. Alright, largest and smallest difference. Given a list of integers nums and an integer k, choose elements from nums to create a list of length k such that the difference between... Yes, I'm kind of salty, you left us all in the dust, but yeah. Nice. Quick, it's very quick, and that's very nice. Given a list, okay. In the list, and the smallest integer is minimized. So, I think the way to really do this is to... kind of curious, is it greedy? It's not greedy. Okay, because the solution that I can think of here, right, is to first of all, sort the list, start from the middle, and keep adding at left, then right, until we get to k. This will allow us to minimize the difference, I think. No, it actually won't. It won't allow us to minimize the distance. Because 1, 2, 5... Small brain. So how, okay, because my logic was that the middle elements would allow us to... I think actually what we can do is to say, we start from the middle element, right? Start from the middle, and then what we do is say, is the difference between left or right smaller? Add that number. Then we keep track of where left and right is, and always add the smaller difference. So, because the reasoning behind this, right? Let's say we have the list that's in here. Sorting it would give us 1, 2, 5, 8, and 10. We do n over 2, which is 1, 2, 3, 4, 5. 5 over 2 gives us 2, 0, 1, 2. That's 3 and 3. 6, 7, 8. 3, 4, 5. That's the same difference, though. I'm not sure how we would actually, in these cases, do it. I mean, I guess, because the difference here is 4, 2, 3, 4, 5, 6, 7, 8. What if we were to do a sum all the way to the left and all the way to the right? And then, goodness, Archer, you want to drop a hint here? Because this is, it's kind of tough. Let's see what this hint is. Okay, well, a very good hint. And it tells you that sorting helps. So, sliding window. Really? I guess that the window just needs to expand. Doesn't really need to. All right, let's try it. Okay, let's start writing code, because without writing code, we're never going to get anywhere near a solution. So arrays.sort. We're going to sort nums. So sorting nums will allow us to then look at n over 2, right? Array list array list of integer list equals new array list. Cool. So let's first of all, I think the best practice really is actually, what if we were to, let's say, start at the beginning? Does this list have a remove method? I thought I had an idea, but I guess I didn't. I was gonna say maybe potentially starting at the beginning here could be the better option, because checking, we can see, I think it's large to small sort. You're given a two-dimensional list of integers. Each index I in the rooms represents a room, and rooms I represents different keys to unlock other rooms. You're currently in an unlocked room. Every other room is locked. You can move freely between unlocked rooms. Return whether you can unlock every room. This is just a BFS. Hey, Codefront, thanks for the follow, man. I appreciate it. Okay. Let's get back to this one. So, we need a window of size K. What if we were to... Hey, good to see you, man. Welcome back. Welcome back. Sorting will help. Yeah. Okay. Student place. Okay, let's see. Start the middle. Okay, let's do int a pointer. I think sorting and sliding window, probably. So int left equals 0. Rather, not 0. Let's do int left equals nums.length minus nums.length over 2. Okay, int right equals nums dot over 3 over 2. Why am I doing over 3? While while the difference is less than k. So right minus left plus 1 does not equal k. Here's what we're going to do, right? We're going to say find the difference either side. We're going to start in the middle and expand the window to either side. Maybe not actually. Maybe not that. I'm just trying to think of the way to correctly implement a sliding window here. A sliding window usually goes left to right. And I guess the other question that I do have with regards to sliding window is if we do implement it from the beginning, how can we be sure that later on there wasn't another item of said window that gave us a smaller difference? Wait a minute. Wait. I guess, does it want the list? Doesn't want the list. Yeah, it'll be a subarray. Wait, no, it doesn't want the actual list. Okay, hold on, I have an idea. What we can do is to say k is less than or equal to n less than that. Okay. So what we're gonna do is say while right does not equal nums.length minus 1. We're gonna say left is equal to 0. Int right equals left plus k. Because let's say k is equal to 3 in this case, so we want 0, 1, and 2 to be in there, so it's going to be k minus 1. Then what we can do is say while right, okay, we're going to keep track of the difference. Smallest min diff equals integer dot max value. Cool. So what we're going to say is min diff is equal to the math.min of nums at right minus nums at left versus min diff itself. Because we don't actually care what that list is. All we care about is that minimum value. So we're going to do that. And we're going to bump up left plus plus and then right plus plus. Cool. Return min diff. This should just be it. K minus 1, that's okay. That's just a missing semicolon. Integer.max value, semicolon, that's just a full-on colon. That shouldn't even be there. That's so slow, man. Nums 0, K1. Expected 0, okay. If nums.length equals 1, actually, you know, we don't even need to do this because this needs to not be this. It needs to be right nums at right minus left. There we go. Just like we're doing here to find that initial min diff. Ooh, so close. Okay, the expected here is 0. We're dropping that. Got him. Easy. Okay, yeah. Once the realization hit me that we don't actually need to find the full array, we're fine. Very, very nice problem once you really understand what it's doing. I was trying to overcomplicate this a lot. Cool. Let's go on to the next one here. Unlock rooms. You are given a two-dimensional list of integers rooms. Each index I contains rooms and keys to other rooms. Sweet. So room 0, for example, connects to room 1. Connects to 0 opens. Wait. You can move freely between Each index I in rooms represents a room, and rooms that I represents different keys. Okay, so I think first thing that we need to do is do a set of integer unlocked rooms. This is going to allow us to keep track of the rooms that we have unlocked. Okay, the print statement. Cool. Then we start in room 0. So I guess what we can do is make a queue. Integer to visit queue equals new like list. Cool. So we are in room 0. Need to head out. Good luck. Hey man, best of luck to you as well. Best of luck to you as well. Okay. We're gonna add 0 to the queue. So I'm gonna say while not queue.is empty. We're gonna do int cur equals queue.poll, and we're going to remove this number from the queue. Then we need to add all the keys to it, to the unlocked room set. Let's do as well unlocked dot put 0 for int I in rooms at cur unlocked dot put I, as well as add that to the queue to then traverse it. As well as adding it to the queue. Let's go. Okay. So queue.put I. Cool. Let's quickly return true here, just to make sure this runs. Queue.add, is it? Add. Is it all add? Unlocked.add. It's always so like confusing with specific syntax for these. Yeah, let's go to TLE. Alright, let's see what we got. Okay. Let's also keep track of visited. Because we're just going to keep looping back and forth and visiting all of these, and it's just going to become a bit of an issue. This new hash set. Per and then to say if not visited dot contains cur, we're gonna do this and then move this add to the bottom here. So fast. Cool. Let's do that. Unlock that I. There you go. Q.add. Let's move this in here. Move that up to there. And then after the for loop, we're going to just add it to visit it. Accepted. Right. What we can do here is say it return rooms.length is equal to unlocked dot length dot size, maybe. It shouldn't work. It works. Let's go! Goodness. GG. Good solution though, really proud of it. Great, I mean, half an hour left, not really sure what to do. Alright, so that's all four. Let's see maybe if we can optimize something here. Archie, did you one in place? Okay, I guess for the time being we can go over the solutions to these. So this one is running in n log n time. It's also running in O of n space because we need to use these arrays to store the other ones. Yeah, okay, use extra space. What we're doing basically is setting up a regular forward-facing array and a reversed version of that array. And what I'm doing with this norm variable here is just flipping back and forth between the original and the reversed one, and saying, okay, every other one we need to grab the biggest, then the smallest, the biggest, smallest, biggest, smallest, biggest, smallest, and then by doing so, we can then just grab the, because the front of it is the maximum. Right, I can. Okay, let's see. Okay, so sort begin nums end. Interesting. Okay. I'm not too familiar with C++ code, so I'm not quite sure. Oh, I guess this means sort the entirety of the nums array. Get its size. Vector answer is the result. Dot push back nums I. Otherwise, push. Interesting. I'm not sure what this is doing really. I guess add to the back nums of j minus minus I plus plus. Yeah, I'm really not sure what this is doing, man. The C++ part of it is what's throwing me off. But yeah, pushback appends to the back. Okay, I keep forgetting that like most other languages don't really treat arrays as these like static block things. They're more flexible, like lists in like Java, or lists in JS, or arrays in JS even. You know, I really don't understand how larger streamers talk like this for hours on end, like 2 hours and my voice is already gone. Okay, next solution. Unobstructed buildings. All we're doing is sorting it. We're not sorting it because we need to keep the building order in the same way. Then we go from the right side and always keep track of what the tallest building was and update that as we go. And basically every building that is taller than whatever the tallest building before it was can have the ocean view, and that allows us to basically say, hey, are you taller than the max? Cool, you have an ocean view, add one to it, otherwise don't. I think this is running in, I'll say O of 1 space, but it actually could be O of n space because we need to make that list to actually add stuff to right here, because we need to make the list for our solution. This overhead in Java just kind of sucks because doing an array conversion, list to an array conversion gives you an array of objects when it expects an array of integers, which it does not like. But space-wise, O of n, time-wise, also O of... It's actually n log n for time, which is due to this sort. But overall, I'd say pretty good solution. I'm pretty happy with it. Still kind of slow, but I think that's just inherently Java. Largest to smallest difference is a sliding window approach. Usually, when I was thinking of sliding window, I wouldn't have called this a sliding window because I think of sliding window as something that sort of expands and contracts as it moves along. This is just setting up a window and iterating through the entire list to find what the smallest difference is. It's a fairly simple question once you sort of narrow it down to that solution, but getting here I think is what takes a little bit of time. This one was pretty easy. It's a fairly easy, fairly standard graph question. The wording, I think, intends to throw you off by going into the whole, oh, it has keys that you can visit. The only thing the keys do is actually, it's basically a adjacency list. And these keys, what they allow you to do is to say, hey, from me, you can visit this room. I'm pretty sure these two sets are doing the exact same thing. Which I guess is a little bit redundant. We could probably cut one of them out. Like this one maybe. Let's try it. I mean, I can cut this out here. Cut this out, and let's do visited. Maybe this will work. Yeah, cool. So that was a redundant array that was doing the exact same thing. Because I think the main way to really solve this question is to not get confused by the wording. Because this whole key thing unlocks rooms. You can't visit a room regardless if the adjacency list doesn't have a link to it. So I think that the time complexity for this, space complexity is O of n because we're using the set and the queue. But time complexity, if I'm not mistaken, for adjacency lists solving problems, your complexity is going to be v plus e. I'm going to look that up though. Complexity of adjacency list. Because adjacency matrix is v times e. Yeah, n plus m or v times e. V times e, n plus m or v plus e. V plus e is just how I learned it kind of in university, so that's kind of what I stuck with. But overall, pretty good. Pretty good bank of questions. Man, my voice is gone. Not really sure what to do from here. I mean, there's 20 minutes left, so if there's any questions, I'd be down to answer them. But I guess I can just make fun of the other people. All these people I know. So, I can make fun of them. It's okay. Unlocked. Let's go ahead and just get rid of all the comments and stuff. Resubmit. I'm not sure how you would actually do this faster. But man, I remember maybe... Here, I can actually just put this on to like a cooler pattern for... Ooh, it does not like that one. This one's pretty... does not like that one at all either. But I remember I used to struggle a lot with graph questions. Like, anytime I'd see a graph problem, it would just be the bane of my existence. I would just quit I'd just probably not even attempt to solve it. But over time, I realized that, you know, dynamic programming is the root of all evil, at least from what I'd say. But graph problems were up there. But really, once you figure out the 2 or 3 basic patterns for graph problems, they tend to be the same. 800 problems on LeetCode. See, this is where the legend comes in. But yeah, graph problems have a tendency to either be implementing a BFS or a DFS on either an adjacency list or an adjacency matrix, or a... Yeah. And I think the main thing is to just not be intimidated by them. Because if you do end up sort of allowing yourself to get intimidated by the thought that it's a graph problem. Is there any way to watch your earlier prep streams? Only a few of your prep streams are accessible on Twitch. Yeah, I wish that I could have saved it to YouTube, but YouTube wouldn't let me upload the full 2-hour VODs. So I wish that I had the opportunity to do that. Maybe at some point I can figure out how to get like verified and be allowed to do that, but as of now, it just would not let me. It would be really nice though, because you'd be able to see me struggle from the very beginning. My camera does not like that one. The cool thing about this one is that you can kind of turn lighting effects on and off, as well as changing the color palettes for them. My one gripe with this keyboard is the fact that it is a 60%, so I have no function row, I have no buttons here, so pretty much anything that requires me to use those other rows I have to do on my kind of main laptop keyboard. And the other thing is, if I want to type a backtick, there's also, I think, 3 separate rows of macros that you can have access to. I guess those rows of macros are not an issue at all usually, until you swap keycap sets like I did, because the original Keychron keycap set had all of the macros written in, but this one doesn't, so I genuinely have no idea what half these keys are. There's a way to like change Bluetooth device connectivity. I don't know how to do that. I've never bothered to look it up. What's like a nice one to leave it at for now while we're just going through this? But yeah, there is a way for me to like auto upload these things to Twitch, to YouTube rather, but not sure how to do that. If anyone has that experience and can help me out, I'd be very happy to get that help. So Van Joint, see you're here for the first time. So what have you been up to? What are you working on? Oh, hey Van Radius, good to see you. It's a lot calmer in here today. A lot calmer. No people spamming. No having to ban people anymore. Gonna follow along from the new series from day one. I'm learning DSA. It will be beneficial. Can you suggest some other video resources? I learned better using guided resources. That's a great question. One thing I can offer you, I'm not sure how much help it'll be, because I personally learn better from just like trial and error and looking at solutions, but there is a link I can provide you to the LeetCode main server. It's a LeetCode server that has, let me see how many members there are really. I know there's a lot, couple hundred people in it, but it's just like a LeetCode server where people discuss solutions, they do mock interviews, they do things like that. So I think that should help you a lot. There's also one more thing that I can suggest to you. Our professor from our university has been doing his best to make his sort of education, BFS, has been doing his best to make education kind of available to many people, and I know it's a very long series, but I can link you to this playlist. It's publicly accessible, so I really doubt that it would be an issue. This is how I learned my algorithms. From my sort of university's algorithms course, has 53 videos. They are pretty lengthy, but it goes in depth and very clearly explains all the concepts of data structures and algorithms. And if you want, you can take a step back. He has a course on discrete math as well, which will cover things like big O notation, Boolean algebra. It'll cover identity proofs and things like that. So yeah, those are probably my 2 biggest recommendations. And the other thing that I can tell you is just practice. I mean, if you don't really, intend on doing things like solving LeetCode questions daily and things like that, but if you want, make a small project. My data structures course, the only reason I am as good as I am at trees or anything along those lines is because of the amount of time I spent practicing trees, especially like linked lists. I remember our second assignment, I sank about 40, 50 hours into it because, keep in mind, right, at this point, linked lists are fairly simple to look at, fairly simple to use because I've been working with them for so long. But at that point, I had just started, and we needed to build out a linked list of our own, and then implement bubble sort on linked lists, which was a nightmare because pointers and pointing things and swapping rotating pointers was a nightmare. And then implementing shell sort on a linked list that you wrote yourself. That was the true nightmare, and I think I stayed up till 4 a.m. for like 3 or 4 consecutive nights working on that. And the exams, let me tell you, man. There's, you know, some professors won't go too in-depth, but when your exam on a topic consists of by hand remembering, building out, removing, adding from, what's it called, from, you know, just binary search trees, any regular tree, balancing trees, working with AVL trees, working with red-black trees, working with B trees, all of these things. It's just practice. So that's probably the best advice that I can give you regarding that. Yeah, I only know DSA syntax in Java. Man, I have been live for 2.5 hours. Yeah, for sure, man. I'm happy to help. If there's ever any other questions you have, you could... It's not a command that's publicly up here, but !Discord will give you a link to a small Discord server that I just put together for, you know, sharing solutions, sharing screenshots. It's not particularly active, but it's a place to, if you really want, like, send in questions. Hopefully, you know, somebody would be able to answer. It's a way for you to reach me directly, if anything, and, you know, feel free to ping me, and I'll do my best to help out. Working on C++ and Python for problems now. And JS over the winter. JS is so simple. So slow. C will be less verbose. Dude, I've seen people write, like, nuts C++ code. I think one of the solutions even... yeah, I think Van Radius is actually in that Discord server, but... Yeah, there's some really cool C++ code I haven't seen in here. I'll see if I can find it. Hold on. Because it was a really, really cool... let's do... okay. Where is that snippet? There it is. Let me see if I can open up the original here. So yeah, this was a C++ solution to k-distinct window. I don't know how to write C++ code, but just so given a list of integers, integer k, return the count of distinct numbers in each window size. Not a very difficult question. You set up your window, slide it along with a hash map, add new one, remove old one, and then just make a count. The amount of, like, look at this. If not minus minus m of v of I minus k something something d minus minus, if not m of v of I something something plus plus, like, what is this, dude? This is probably like the nuttiest C++ code I've seen. But it's pretty cool, and it worked, and it was fast. Though I really don't think that this is something you should pull out at an interview, because it is in fact not human readable. And if I'm gonna be honest, I worked at my internship, and I came across some things like this. And this was a nightmare because not only was I familiarizing myself with the code base, I still had absolutely no clue what was going on. Oh my god, 8 Twitch viewers. I wonder how many of us are those. Yeah, no, gave up on 4. What do you guys think of this new kind of keyboard camera? Because, I mean, I'm debating keeping it because I think it just looks cool. And, I mean, this long sleeve shirt, the fact that it's dark enough to where it blends in, it covers my wrist and takes away that, like, scary looking part of this. Covers my wrist and it just looks like my hands are floating, which is pretty cool. Oh, that actually does kind of look like... Yeah, I don't have a second camera, man. The worst possible way to implement the first problem, but it works. CSSE.fi. What is this? Let's see. Ooh, code submission evaluation system. That's cool. Yeah, here, I'll send this one into the chat as well. Yeah, I wish I could have 2 cams, but I can't justify spending another like $50 because this webcam cost me like 60 bucks. I also don't have anywhere to plug this webcam in, man. I'm telling you, I'm already running every single port. And you can't hear it because thankfully at least the camera somewhat blocks some of the noise, but my laptop sounds like a jet fan every time. But yeah, I guess it just depends on a day. Sometimes might move it up to the face, sometimes might keep it up at this. I think the candle gives it a little bit of nice ambience. And you also can't, because it's dark, you can't see the mess that is my desk. Okay, what are we gonna do now? I'm gonna do contests on leak code. Got like 1 question with the additional cases on submission. I'm not even sure what to do anymore, man. We got 10 minutes. I might just stock other people's solutions. I wonder if anyone's actually still working. Daniel's given up. I don't think anyone's still working on this stuff. Hey, okay. You know, the room aspect of it is what I really like because it allows you to really collaborate with people, and what's it called? What was I saying? And I guess help others along. And the chat function is really nice as well. Trying to unlock that little problem-solving ability I have left. I think, honestly, I'm probably going to cut it here. I've been live for 2.5 hours solving these problems. I need to go do other things today. I haven't really eaten today, so I think I'm going to cut it here. Thank you, everyone, for stopping by. Hopefully it was helpful. Hopefully I was able to give some insight on at least something. But yeah, that's going to be it for me. Where's my... Yeah, there it is. That's a thumbs up. All right. Thanks, everyone, and I'll see you guys probably Monday, 10 a.m. PST. Thanks for stopping by.